welcome folks who had not been here before, to just let them know that you can go to our past meetings here. You can watch the recordings. We record each, in fact, this is being recorded right now, just for your information. And we upload them to the ESIP YouTube site and put the link in here so you can watch this or share it with folks who you think might be interested after this presentation. So, oh, and one more thing, I guess, if you want to be notified of these events, if somebody forwarded you the email, you can click back here and go to the Interoperability and Technology Committee page here, and there's a sign up for the email list right here. Okay, so well, we're very happy to have with us today Jess Walker from USGS to talk about Google Earth Engine. I'm not going to give any summary of her talk. I'm just going to let her talk. So I'm going to switch over to you, Jess, and let's see here. First, I have to find you. Okay, here we go. Not connected to audio. Oh, but you are connected to audio.
Yeah, I'm on the phone.
Okay, let me try this. Hope you're not logged in multiple times, but okay. Can you share your screen?
Yep.
Okay. I'm gonna hold on a second. I'm gonna mute everybody and unmute you. Okay. Can you, Jess? Okay. Jess?
Can you hear me now?
Yeah. Okay. All right. Take it away.
Okay, great. Well, thank you, Rich, for organizing this. Hello, everyone. As the slide title shows, this is an introduction to Google Earth Engine. So it's really a very low-level, sort of basic introduction to the Earth Engine platform for those of you who are only vaguely familiar with it or who are wondering what it's all about and how to get into it. And make sure I can. So what I'll be going through is, again, just sort of some of the basics of Earth Engine, what it looks like when you get into it and how to manipulate some of the data, and then feed into some of the applications and ongoing projects that are using it, with a particular emphasis on projects that some of my colleagues at the USGS are doing in terms of Earth Engine utilization. And finally, how to start using it if it seems like something at the end of this lecture or this talk that you think you'd want to get into. So what is Earth Engine? Google defines it as a cloud-based planetary scale geospatial analysis platform, which when you unpack it and kind of reduce it to its very simplistic basics is it means that Google stores imagery on its servers. Users write scripts to view, process, and analyze that imagery on their web browsers. Google then executes those scripts, those individual commands, and returns the results. And the planetary scale aspect of that description comes into play when you unite the data, the vast data holdings that Google has, with the processing speed that Google's capable of. And you really come up with this potential for analyzing planetary, or conducting planetary scale analyses that are unprecedented both in terms of their spatial and temporal resolutions. So when I talk about imagery on the Google servers, I mean a lot of imagery. The most recent hard figure I've seen was sometime last fall, which said that there was just over 5 petabytes on their servers. So there's a lot of data in a public data catalog, and all the data are pre-processed to some extent, and they're geo-referenced, so they're pretty much ready to use. The link that you see there, I believe that's only accessible if you have an Earth Engine account. Someone might be able to correct me if I'm wrong on that, but you can access and view all their holdings. The two biggest ones that Google possesses are the Landsat and MODIS holdings. They're really trying to replicate as much as they can the complete collection of both imagery holdings. So Landsat, for instance, has all raw data for Landsats 1 through 8, as well as top of atmosphere and surface reflectance data for Landsats 4 through 8. And then it has a host of derived products and various compilations, such as burned area index, enhanced vegetation index, normalized difference snow index, normalized difference vegetation index, water index, etc. There's a lot of data there. Similarly with MODIS, there's as much of an effort as possible to replicate the entire MODIS archive. And so there's daily data, there's NBAR, there's LST, and there are a host of composites ranging from 8-day to 32-day, whatever your favorite composite time length happens to be. So those are sort of the most complete in terms of spatial and temporal extent data sets. There are multiple other remote sensing data sets that Google also is ingesting, and these may be more or less complete both spatially and temporally, but they do have data to offer that you can use. So there's the high resolution NAPE data, Sentinel-1 and 2 are being ingested. There's SPOT, Terabella, which is Google's own foray into the satellite imagery acquisition business. They're setting up their own constellation of sort of mini satellites. AVHR, Pathfinder, there's a host of miscellaneous other data sets. And finally, there's land cover, there's an LCD, atmospheric, and terrain. So overall, again, there's multiple petabytes of data readily accessible and publicly available. And data sets are continually being added in addition to Google's own internal list of data that they're ingesting and what they have in terms of their priorities. Users can also submit requests for particular data sets that they would like to see added to those holdings. Again, I think this link is only accessible if you've got an Earth Engine account, but if you do have one and you go to that URL, you can see that there's a mechanism by which users can both input new data set requests, or they can kind of prioritize ones that are already existing. And you can see that I've starred a number that I personally would like to see added to their holdings. And Google's kind of working their way through this particular list as well, as licensing restrictions allow. There's not every data set is going to have the permissions on it that will allow it to be ingested into their public holdings. So those are the data, the publicly accessible and sort of commonly archived data sets. In addition, if you're working on your own particular analysis, you can integrate your own raster or vector data sets into your analysis. You can upload rasters of up to 10 gigabytes for an individual file size, and vectors have a somewhat lower limit, 250 megabytes or 500,000 records, whichever comes first. And these are uploaded to your Google Drive, and you have 15 gigabytes free across all Google Drives. That includes Google Drive. There are some exceptions to that, I believe. Documents that you create, such as Google Sheets, don't count against that limit. Gmail and Google Photos as well. If you break through that 15 gigabyte barrier, you can purchase more space on a sort of monthly fee. The table to the right shows exactly what those space options are, anything from 100 gigabytes for $2 a month up to 10 terabytes for $100 a month. And I'm sure if you have space requirements that are larger than 10 terabytes, Google would be able to accommodate you. The files that you upload personally can be shared either publicly or privately, so you can toggle whether or not these files are something that everyone can access and use, or ones that only you can have access to. There are two ways of interfacing with Earth Engine. This first example is the graphical user interface, the GUI, which is sort of the lightweight way to access Earth Engine. And it's good for examining data sets, sort of seeing how things look and getting a sense of where the data are and what it is. And you can perform some low-level computations with the data, ranging from masks to pixel thresholds. But this is sort of again, it's sort of the lightweight version, and it's it's good for graphical display, but it's not the real Earth Engine interface, which is this one, which really gives you access to the full capabilities of the platform. So this is what Earth Engine looks like in the JavaScript code editor, which is also called the Playground version. If you open it up and there's absolutely nothing in it, and you can see the breakdown is sort of 3 boxes across the top and this graphical display at the bottom, which defaults to the Google Maps kind of standard background. And essentially the three boxes across the top are organized into input and reference, coding, which is where you put all your code, querying tasks and status, and then output and display at the bottom. And I'm going to go through each one of those just to familiarize you with what this code editor, what each one of those individual aspects can do. So that was sort of the out-of-the-box look at the code editor. And this is another view of the code editor after there's been some sort of coding taking place. And what you see here is a subset of the high-resolution 2-meter NAIP data showing the University of Arizona campus. And again, it's got that default Google Map backdrop of just to orient you. And the yellow circle at the bottom there is at the southwest corner of campus is where the USGS building is and where I'm currently sitting right now. And you can see that the boxes up above have been filled in with various text. And I'm going to go through those. So each one of those boxes has a number of tabs associated with it. And so again, on the far left, you see a tab scripts, and as you might assume, that's the script manager. And there's sort of very basic functionality in terms of being able to organize scripts. You get essentially folders, and then you get individual scripts that you can place into those folders. And I don't know if we try out the cursor. And these particular icons, one of the more interesting ones is on the left here. That's a rollback kind of icon, and it has to do with the fact that these scripts are along the lines of Git versions, and so you can roll back to previous editions if you want to. Docs is also, as you might suspect, gives you some information about the documentation that goes or that underlies the coding. And so if you have a question about one of the particular commands and you click on its documentation link, it'll bring up this box that shows you input arguments, basically what it does, input arguments, and then what it returns, the format and such. So it's a very straightforward and relatively simple way of knowing exactly what the commands do. Assets will show you the list of the uploaded raster files. These are files, again, that you've personally uploaded that you want to integrate into your analysis. And it gives you, with that new function or button there as well, it gives you the opportunity to start that process of uploading right from there. So skipping over again the code editor, you can see there's some native formatting functionality built in. Comments, for instance, are automatically put in particular colors, and so are some of the functions and some of the basic variables in text. With map output, again at the bottom there, it's not entirely static. You can use these symbols over here to be able to create points, lines, and polygons. And I've just dropped an example of some of those onto the screen right there. And what you can see is that in the code editor, the points, the poly, and the line have become active geometries that can be used in the analysis. So I could take that geometry, that polygon geometry, for instance, and use it to query the values within that extent, for instance. Similarly, I could use the points to query values at those locations. Get script URL is triggered by the get link button. And when you click that, this is one really neat aspect of using Earth Engine, that generates a link that represents the script as it is at the moment that you hit that button. And you can send that to anyone else who has an Earth Engine account, and they'll be able to bring up your exact data and analysis as it is and results. The caveat on that is that you have to set your data to a setting such that they can access it. It can't be entirely private. But that's a really neat way of being able to share code very easily and very efficiently with whoever you want to share it with.
Yeah,
script. Excuse me?
Never mind. I was just going to say that is super cool.
Yeah, run script does exactly as you would expect it to. Inspector, when you click on that tab, it changes your cursor to a crosshatch, and when you click on the graphical display down here, it will query the underlying layers at that point. So I'm not quite sure exactly what point I clicked on, but wherever it was at that particular longitude and latitude, and it gives the values of the NAPE imagery at that point for red, green, blue, or near infrared. And what it's also showing you here, and what you can't see from this particular example, is that I had generated 2 other layers of imagery that are stacked underneath the one that you see here, an NDVI and a standard deviation of NDVI. And it also gives you those values for any layers. So it essentially just drills down and gives you information about what's at that particular location. Console, there's the helpful little advice to use print to write to this console, and that's exactly what you do. You can print text, you can print anything you want. The helpful thing with using print is that if you print a particular data set, it gives you information about that data set. So for example, the NAPE details that you see in that box right now are the result of my issuing a print statement on the NAPE data itself. And it tells you what the image collection is, gives you some basic metadata about it, and then goes into the properties and will give you the values at data ranges for particular bands, etc.
Hey, Jess?
Yes?
This is Ted Haberman. I just had a question on, just bugged me a little bit on that last one. You said there's an NDVI image under here that's not showing, and then you showed the standard deviation of NDVI. Is there an image of that? Is that the standard deviation that was created when NDVI was gridded into this resolution, or what is the standard deviation of NDVI mean in that case?
Oh, good question. Sorry I didn't explain that more. That's a separate image that I created using a neighborhood parameter to calculate the standard deviation of NDVI within a particular neighborhood. So it's not an inherent data layer that comes along with NDVI or the creation of NDVI. It's something that I created and explicitly sent to the display as well.
Okay, and you just sort of average that over pixels that are within some distance of this pixel or something.
Exactly.
Yeah, okay, cool. Thanks. Sorry for, I was
a
little confused by that.
Yeah.
Hey, actually, Jess, while you're taking some clarification questions, is the code that you use there in the middle, are there options for what kind of code to use, or is that JavaScript that you have to use there, or?
You have to use JavaScript. Yes.
Yeah. Okay. Okay. Thanks.
Yes, and actually, getting back to the standard deviation question, you can see I've used a kernel of size 7 and taken the standard deviation within that area. So this is the actual code that generated the standard deviation, and then I've simply added the layer down here. So.
Cool. Good.
Okay, so let's see, so the last tab that we're looking at here is tasks, and this is where any command that is not something that's immediate, something that kind of triggers a longer process. For example, like an export, if you've drilled down through a bunch of layers and you want to export all those values to a CSV file, that gets turned into its own process, its own task, which you then have to manually set off. So you would click run to each one of those various processes that you've embedded in the script. And that launches them, that sends the request off to Google, and it begins the process of executing those commands. You can see in the bottom under older tasks, ones that have actually completed. And so you get a little bit of a history going there as well. So that was the JavaScript API. You also have the option of programming in Python. Both APIs have the same Earth Engine backend. They rely on the same protocols. There are some differences, both minor and kind of more substantial between them. The JavaScript, the JavaScript version is used by far the majority of Earth Engine users. There's much more support for it, and there's much more use of it, so that ultimately generates or results in better coding assistance. If you run into a problem, you'll more likely than not get a faster response if you're posing a question related to the JavaScript API. You also have that option of using the link to share your scripts directly, which is not a functionality of the Python API. It's also deeply integrated with Playground, so it gives you faster algorithm testing. One of the drawbacks is that there's no module support, so it's hard to organize long code. So for instance, if you write a function that's applicable to 20 different individual scripts, you can't have a function call in each one of those scripts. You have to embed the function directly into each one. So that can result sometimes in some unwieldy code. The Python, Google explicitly recommends it only for the development of operational apps. There's a higher threshold for entry into Earth Engine and to becoming familiar with Earth Engine through the Python route. There are fewer users, so there's less coding assistance. That said, it has much better support for task and asset management. If you're running an operational app, something that you need to generate products on a regular basis, for instance, you don't have to go in and manually hit a run command. So it's much better suited for that sort of goal. And Python API is also good for statistics, data analysis, and plotting with Python packages because it does have access to all the scientific libraries that are associated with Python. So once you hit run, what happens? Earth Engine relies on a parallel distributed system, which means that analyses run simultaneously on many CPUs across many computers. And there's a picture of one server room in Council Bluffs, Iowa, one of many server rooms, and one of many server rooms stuffed with many, many computers. So you get some really fast analysis capabilities. In a test case, I wanted to retrieve all available Landsat images for a given location, so Landsats 4 through 8, 1982 through 2016. I applied a cloud, water, and shadow mask, computed multiple vegetation indices, and requested the export of a CSV file of values at, I think I had 4 or 5 different locations, all granted within the same or contiguous Landsat scenes. But that entire process took about 9 minutes. So one thing that Earth Engine does is that it caches results, so that if you're repeatedly issuing the same command, those results, or the generation of the results gets faster depending on how much has been cached. And so after caching, after running it once or twice, that process took about 3 minutes. And so it's very fast.
How long do you think it would have taken you to do that task if you didn't have Google Earth Engine?
Oh, downloading all Landsat images, months maybe?
Yeah.
At least on the order of, you mean the pure just like having the images and sampling through it, or actually retrieving all the images to my computer and then running the project?
The latter. I mean, that's what would be stuck with if we didn't have Google Earth Engine, right?
Exactly.
She would still be doing it, Rich. She would still be doing it.
Yeah. especially after my hard drive failed. Then I'd be doing it again.
Right.
So that again, so you've seen sort of the data holdings and sort of the processing capabilities of Earth Engine. And when you unite them, that's really where you understand where this talk about planetary scale analyses begins to make sense. The first demonstration of the overall capabilities, or at least the large scale capabilities of Earth Engine, I believe was really Hansen's work in 2013 out of the University of Maryland with the Global Forest Cover Change Project, which calculated forest extent, loss and gain at Landsat scales over more than a decade. Used a lot of pixels and a lot of images, and there was close collaboration with Earth Engine personnel to complete it, but it was really a benchmark project in terms of demonstrating where you could go with Earth Engine and signaling that this was sort of a new paradigm in terms of what you could analyze and how long it would take you to analyze that. And so there have been a growing number of diverse applications that are taking advantage of this platform. Google is pursuing its own particular demonstrations. There's the time lapse, for instance, in which they assemble cloud-free Landsat imagery over various places on Earth and make time-lapse images that show the change over 30 or 40 years. And then there are a host of different research agendas that have begun to explore Earth Engine as well, ranging from multi-temporal settlement and population mapping to tracking changes in critical tiger habitat. So there's more and more that are beginning to use this seriously, both for operational and for research purposes. And so now what I wanted to do is just walk through, I think I have 5 different examples of applications in the USGS that are using Earth Engine as the prime mechanism for their analysis. And starting out, there's Roy Petrakis in Flagstaff and his crew. They're using Earth Engine to assess burn severity and vegetation conditions on the San Carlos Apache Reservation in Arizona, and using Earth Engine to assemble the different rasters that go into the analysis. And this is also a great example of how you don't have to be global in scale or take advantage of the full time series of a Landsat archive, for instance, in order to really make functional use of Earth Engine and its processing. Kristen Bird out in Menlo Park, as well as many others, are looking at really pushing a forward-looking, consistent, remote sensing-based methodology for quantifying above-ground tidal marsh biomass in different areas, and again, using Landsat to extract surface reflectance values at various points. And the point about the post-processing of Earth Engine output in a relational database is one that I think you'll see in quite a number of different projects, in that you get the data that you want out of Earth Engine, and then you use it to, you actually compute statistics or do some finessing of the analyses in a different software package. And the drawback of Earth Engine that's noted there is that there's some erratic response time at intervals and some random server-side failures. And every so often you'll see on the Google Earth forum like a bunch of people chiming in to wonder why their 9-minute processing time has suddenly exploded to an hour or more. And it's usually something that Google has to simply go in and correct on their end. But that does happen. It's still very much an evolving platform, and it's got those evolving platform kind of problems. So moving forward into taking advantage of the time series aspect of Earth Engine, Eric Waller and others out in Menlo Park are looking at vegetation recovery at abandoned oil and gas pads across the Colorado Plateau. And again, looking at a wide distribution of sites and drilling down through an imagery time series to extract values at those particular locations. And again, here I happen to know that they are taking the results of that output and analyzing it in another package, in this case R. Some work that I'm doing to look at the phenology of dryland forests after wildfires, again using more of the temporal richness of Earth Engine than its spatial extent. I'm looking at different point locations across the Southwest and extracting at each one of those points the full, as much data as I can, in essence, from the Landsat archive. And again, same as many others, I'm taking those points and I'm doing further analysis and statistical manipulation in R. Over at EROS, sort of exploring the spatial extent possibilities with Earth Engine. They're looking at operationalizing, or at least regularly outputting the ET maps. Right now they're focused more on sort of basin-specific ET analyses, but the plan is to regularly be able to put out CONUS-wide ET maps, such as this one, which would be at Landsat scales, which would be a phenomenal product to be able to access and use. And finally, a true global application from Poseidon June up in Flagstaff, using both Landsat and MODIS data to classify world's croplands. Again, this is something that would not have been possible without the data archive and the computational capabilities of Earth Engine. And lest you think that we only use Landsat and MODIS data, the TNES up in Flagstaff is really pushing the boundaries of Earth Engine by using hyperspectral data to accomplish data analysis related to global food security. And it's been interesting to talk to her about her experiences with hyperspectral imagery in Earth Engine because, again, they are very focused on certain data holdings, and so once you veer off into some new directions, there are some unexpected complications that come up in terms of processing data. And so the pros and cons of GEE use, I think the pros by now should be pretty clear. There's a phenomenal advantage to getting away from the paradigm of downloading and storing data locally. It's really, for anyone who's kind of come up with that particular modus, it's phenomenal. I recently started working in Alaska, and the first time I had to analyze some data or analyze data collected at points in that region, I simply typed in new coordinates for the points and ran the same EE script that I've been running over my southwest area. And it was really sort of a heady experience to not have to download something to my computer, to simply be able to, within minutes, port that entire analysis to a new location. It's kind of exhilarating. So there's that advantage. There's also the fact that Google is offering access to petabytes of data, and there's more continually coming. It's a phenomenal amount of data that's publicly accessible. And then again, the computing power goes for, or makes for extremely fast analyses. So some of the cons, there is programming required. I think for most people who deal with imagery, that's sort of a given. But if you don't want to program, you're going to have to find someone who can do it for you, because it's definitely reliant on sending scripts to the servers to get your processes accomplished. It's dependent on an internet connection, which again I think is also something that we tend to take for granted now, but that is a consideration if that's something that's less than reliable for you. The primary focus is on raster-based imagery. This is not a substitute for ArcMap. This is something that does not have that kind of functionality, and I'm not sure they're going there either, but raster is right now their primary focus. And finally, the one that trips me up on a fairly regular basis is the lack of mature and detailed documentation. This is very much an evolving platform, and I think Google's been working hard to backfill their documentation as they go along, but still in some cases the technology outstrips the documentation of what the technology can do and how you can use the technology. And so the tutorials, for instance, are comprehensive, but they're mostly simplistic examples. And once you step beyond those, there's a gulf of information at times in terms of how to progress into processes that are more sophisticated and more intricate. And neither pro nor con, but slightly unnerving, is the fact that this is all dependent on Google's good graces. And I've had so many people ask me about why they're doing this and what the potential downside to having a commercial organization offer a free and freely accessible, wonderful research platform. That I've taken some words from Noel Gorlick, who's one of the Earth Engine co-founders, and this is drawn from a slide from a presentation that he gave. Why is Google doing this? One of their missions is to organize the world's scientific information and make it universally accessible and useful. And to that end, their goals are to, their specific goals with Earth Engine are to remove access and capacity barriers, foster open science, and promote transparency, reproducibility, and collaboration among scientists. And so anyone that I've talked to in the Google Earth Engine realm, any of the Google technicians and staff and personnel are committed to this. They maintain that there's absolutely no downside, but if you are, if there's a cynical side to you, you might be wondering how far Google is going to go with this before they either get bored or they decide to turn it into some sort of commercial enterprise. For the time being, at least, I have to take it at face value that they are really committed to this sort of free and open access to this platform and that they intend to keep it going. So if that last point didn't dissuade you, how to start using Earth Engine. The first step is to register for an account at that link right there. You have to give a 1 or 2 sentence or some sort of brief description of what you want to use it for. It's not something that you automatically get. I'm not quite sure at this point how rigorous they're being with the, or how discriminating they're being with their decisions about who gets access and who doesn't. It seems like I think there are over 10,000 users at this point, so they must be just churning through these. Note that you can sign up for a USGS.gov account or presumably a DOI account, but doing so limits access to Google Groups, and it also limits access to vector file integration, which is the fusion table mode that, well, fusion tables are how Google integrates vector files into Earth Engine.
And that's, could I just say, I think that's a limitation of the USGS's Google accounts, not anything else, right?
It is. In fact, I received word a couple weeks ago because I looked into it again. Bison Connect restricts access to Google Groups for security concerns and has no intention of opening up that access.
So for, yeah.
And I believe that's, I would assume that's DOI wide, although I'm not sure about that. So what you see on the left is what you see if you try to access a Google group with a USGS.gov account, and what you see on the right is the form as it looks when you are not signed into a .gov account. The workaround that's been recommended to me by our IT folks is to create a GE or work-specific email account and use that to register for Earth Engine in order to keep your personal and your professional worlds completely separate. So some resources for getting started, general overview, more detailed introduction. In the detailed introduction, there's a very, I would say, important few links about how Earth Engine works that are kind of buried at the bottom of that, that whole description that I recommend checking out. Some more information about fusion tables. The all-important developers forum. This is something you definitely want to have access to if you decide to get into Earth Engine. It's pretty much the place to go for any questions about Earth Engine. Google folks monitor that actively and are always responding, typically very quickly. And it's the best place to go. Again, getting into or revisiting the whole idea of their documentation not being quite entirely up to speed. You can really mine the forum for particular examples of how people have solved programming conundrums. And again, the fact that everyone includes a link to a script is invaluable because you can simply copy those scripts and into your URL bar and see exactly what they've done. The USGS has a small Earth Engine forum where we can kind of talk about Earth Engine ideas and activities on a more local level. And then finally, there are a whole bunch of training sessions that are posted on YouTube. These are the results of, or these were recorded at the last user summit this past May, I believe, at Google headquarters. And so with that, if anyone has any questions, I'd be happy to answer them as best as I can.
Well, thanks, Jess. That was a fabulous presentation. I think it's always so much more interesting to get a presentation from an actual knowledgeable user than the vendor. So that was really great. So I'm going to unmute everybody so that they can actually ask you a question. So actually, I've unmuted everyone I can unmute, and so you may have yourself still muted, but you should be able to. Was there a question? Okay.
Hey, Rich?
Yeah, go ahead.
This is Ted. I agree. Thanks very much for a very interesting talk, Jess. Could you how long have you been, just to give us an idea, I assume since you're giving this talk you're a quick learner, but how long have you been working with Google Engine or Google Earth?
On and off for about a year now. So, and kind of equally between on and off. So I would probably classify myself as like a low-level intermediate at this point in terms of being proficient with JavaScript and with getting Google Earth Engine to do what it is I want it to do.
So did you
know? I'm sorry. Did you know JavaScript when you started, or?
No, and the interesting thing is that I did pick up a JavaScript book, and it turned out to be completely useless because so many of the algorithm commands are unique to Earth Engine that I think well, someone with a JavaScript background might disagree with me, but I found it more useful to simply go through the Earth Engine tutorials, and particularly, again, to look at how other people have structured their code and how they formatted commands that were appropriate to what they wanted to do with the analysis. That was my primary learning method, was really mining the forum archives for examples of successful code.
Well, that was going to be actually kind of my question as well. And I think you sort of answered this already in my other question, but it does seem like sometimes it's hard to get through to actual Google folks. But in this case, you're saying they're pretty responsive on at least on the Google groups in terms of, like you can get an answer within a day or so.
Yes, I would say their response rate is really high. I think it's been strained more and more simply because there's been a growing interest in Earth Engine, and there's a lot more activity on the forum. But in general, I'm always impressed by how quickly they get back to people and how much thought they put into their responses. There's some very detailed and very helpful replies that get into coding intricacies, for example, that are it's impressive that they would take the time to do that. So yeah, I found them to be, at least this particular Google group is just, they're phenomenal in terms of their user outreach.
Okay. Any more questions from the gallery here? I see we have 32 attendees. That's pretty good for the TechDive talks. I do have another. So you mentioned that it is only for raster data, but could you imagine saying upload, netcdf files, say containing model output that were, still index based? I mean, does it work? Is there a way to sort of turn your data? What would you have to do to turn your data into something that could be analyzed with these? With Google Earth Engine, does it have to be turned into standard imagery products, or can it read a variety of different things?
Right, so you can upload vector files as vector files. They have to be in KML format, I believe, as the sole criterion.
Well, I was thinking more like, scientific data formats like HDF or NetCDF.
Oh, in terms of for raster?
Yeah,
particular?
well, yeah.
For some reason, I want to say TIFF is the only recognized input format. I'm not.
Yeah. Okay.
But honestly, I'm drawing a blank on that. So I'm relatively certain there would be some sort of finessing necessary, but like I said, I'm drawing a blank on exactly what the format, the permitted format.
Yep. Okay. Okay, I think I'm going to mute people again.
Hey, Rich.
Yeah.
It's Ted again. I'm just full of questions today. In the past, I used to do some things with raster analysis tools by making the x-axis time and the y-axis some like sensor or something, and then running sort of what would be raster row operations, but actually were time series operations. You might be able to do something like that.
That's exactly what I was thinking. Yeah. So anyway, I guess it's worth, I do have an account, and I did some of the, went through some of the tutorials. I was impressed with how easy it all was. So it's probably the next thing for, I should just get on there and try it and see how well the forums work for those kind of issues, I guess. Right, Jess? Is there any limit on the amount of computation? Have you seen any kind of thing about it? Limit on the computation. I think you mentioned how much disk space. Is there any limits on processing? Or I guess you don't even really see. Everything happens behind. It's sort of magical, right? You don't know how many processors you're running on or whatever. It just does it.
It is magical in that sense. There have been, I know at the user summit, one person was, there were some stories from the Google people about users who had stacked up thousands of data queries, for instance, and essentially it didn't cripple Google, but it certainly slowed everything down for anyone else who was trying to put a process through the system at that point. And so they do have some thresholds in terms of computations, both in terms of how long they take, and I think in terms of, well, I guess that would be the primary concern for them is how long they take. And at a certain point, they will time out on you. And so that is one thing that was frustrating at the, part of the frustrating thing is that sort of opacity. You don't know exactly what's going on in terms of what's holding back a submitted process, whether it's something that you've inadvertently set to spawn an infinite number of requests, for instance, or if it's just something on the server side that's a hang-up that Google is aware of. So I guess that's a circuitous answer to your question. There are processing limits, and I'm not sure if they even publish them. They do kind of have their own internal measures for what is permitted and what kind of goes beyond the pale in terms of what you're asking Google to accomplish for you.
Yeah, I guess that makes sense. I mean, otherwise, with unlimited free use with unlimited resources probably is not a very good compute system.
Right, and I have seen on the forum, someone will say, well, why isn't this working? And the answer will come back, well, you're trying to process the world at 15 meters, and so we're not going to do that, essentially. So.
Right. Okay. Any other questions?
Hi, this is Leslie. Sorry, this is Leslie Shi from USGS. Jess, thanks a lot for giving this talk to us. I was wondering, besides informing us about this great tool, is there any other outcome you would like for giving this talk? Like we should go tell all of our friends to start using this, or you're trying to look for more users within the USGS or others doing similar applications? What do you want us, the listeners, to do after this talk?
Oh, that's a great question. Yes, I kind of came away from once I got into Earth Engine and once I did sort of quell my own internal fears that Google would get us all hooked on this and then kind of yank the plug at some point and I'd go back to downloading data. I really became a sort of very much an evangelist for this platform. And so I guess my main goal is to let people know that there is this alternative out there to downloading data, and it's very accessible, and it's something that if you think is interesting, you should be able to take advantage of. And also, I do want to see more of I would love to see more of an adaptation of this technology within the USGS, because I think so many of us have in our analyses the potential to take this and run with it in ways that are, again, both either for operational or for research purposes, ways that would be really beneficial to getting analyses completed both more efficiently and quickly than before. So yeah, sort of on the wider scale, I think it's just such a neat technology. It deserves to be widely broadcast. And within the USGS, I'd like to see more people taking it up, and because I think ultimately that helps us all. One of the things that I really found frustrating when I was starting is that I felt like one of the lone voices in the wilderness. I'm the only one in my office who uses it. I wasn't aware of many people out there who were using it, and so that made me. It felt like I was working through some of the initial startup issues all by myself. And so I think the more people that are familiar with it and are using it actively, the easier it will be for others to begin to delve into it as well.
Hey, Rich.
Yes.
Jess has expressed some interest or some consternation about Google pulling the plug, and of course this is America, so we believe that competition is a good thing. You might want to try and track someone down, or maybe someone in the audience is this person or knows this person who's doing some stuff with similar data sets on AWS. I just chatted a URL, which is pretty easy, aws.amazon.com/earth. And this is in many ways similar to Earth Engine, although it's more focused on data availability. But the similar program that's going on at Amazon would be really an interesting topic for another similar seminar.
Well, thanks for that, Ted. Quickly, Jess, have you looked at that at all? Are you familiar with that, or?
No, I haven't. I've only heard about it as a sort of a potential rival to Google Earth Engine. But yeah, I guess for me, it would trigger the same sort of misgivings to some extent in terms of it being Amazon.
Is it free as well, Ted? Do you know?
Well, the head of this program is a guy named Jed Sunderland, I think is his last name, and NOAA. These guys have Landsat data. They also have NexRad data, which is sort of interesting. So they're working with the NOAA Big Data Project, and they of course are doing it. Someone with me. They're doing it for the good of humanity, and they're also doing it to encourage people to use EC2 compute time to do things. But if so they think that people using this data locally in the cloud will pay for it in the long run. But it's still pretty experimental, and Jed has a program which is similar to Google's, where they'll give you a grant I think they're fairly they sound fairly generous for people that want to try and start doing demos.
Yeah, and so that's interesting. I mean, because I think actually it would probably I don't know what you think, Jess, but it would probably make if you're using this for research and depending on it, you'd actually kind of like to be paying for it and thinking that this is the best use of your resources. The free thing does in a way it's cool, but it makes you a little bit nervous, like Jess mentioned, and maybe that sort of proposal model and actually paying for it would make you feel better about it. Of course, you're going to go free if you get it, right?
Yeah, I'll take the free option as long as it exists.
Right.
And I do, like I said, I have been reassured by so many Google folks at this point that it's something that someone mentioned they're doing for the good of humanity, that kind of have to take it on face value. But I also think the more competition out there, or the more options we have for this type of service is also great, because it simply widens the playing field as far as what we can take advantage of.
All right. Well, thank you.
Maybe right. Another thing, Amazon and Google are both interested in real-life stories of how much time this saves. So, in the NOAA case, access to NextRad data increased to 230% of what it was previously, and the load on NOAA servers dropped by 50%. So from an agency point of view, it looks pretty interesting. And Jen has some nice examples of saving time. So,
well, that's why I asked that question to Jess earlier, because if you did a comparable thing with looking at data served from Eros, versus Earth Engine, I'm sure you'd find a similar story there in terms of use. So it is 4 o'clock, so I'm going to end the discussion there, and thank you again for a wonderful talk. This is recorded, so you can feel free to share this when I upload the link, probably tomorrow. And just a little advertisement that next month we will have Derek Law from Esri talking about Web App Builder. So it's like a way to build a web application without being a developer. So thanks, everybody, and we'll see you next month.
Thanks, all.